Hi, welcome to the course Machine Learning with Python. This is the fifth module and the last module for this course. In this module, we will have a look into the Capstone project. Now, just a word of caution. Uh, if in case you assume that you would actually be solving one project end to end along with the coding examples, that won't be the scenario. This module is rather aimed, so there are specifically two aims or two objectives associated with this module. The first objective is to give you a brief about how does the life cycle of a problem look like. So whenever you're solving a machine learning problem, you actually look into something very specific. You start solving with a specific problem. But that is not the case how actually a machine learning problem originates. The origin of a machine learning problem has to do with a rather general problem that comes from the leadership team of an organization. So we'll have a look at how a machine learning problem is evolved. Like what is the first problem they're trying to solve, out of which one of the small specific problem would be a machine learning use case. So that's the first objective. Second objective would be to refresh you through all the strategies and approaches that we have discussed in the previous modules and help you assimilate that learning into this module with the project. So I'll be giving you a data set. I'll be helping you understand the problem statement. We'll also talk about what are the different approaches that needs to be taken to solve this problem, what are the possible alternatives, and are there any roadblocks that you will hit? And if in case you hit those roadblocks, what could you possibly do to circumvent that situation? So this module will actually help you groom for the project, but then actually the hands-on part of the project would be expected to be done by you. So this will be nothing really difficult. It's everything required to solve the project in this module was actually taught in the previous four modules. So let's get started. We'll have a look at the contents that we are going to cover in this particular module. So we can broadly divide the contents for this module into two sections. In the first section, ranging from points 1, 2, and 3, we'll first look into the use case overview. So we'll try to understand how does a problem evolve in nature, how do large organizations understand there's an urgency to solve a problem, and how does that eventually evolve into a more specific problem. Now, once that overview is understood, once we have a brief context about how does a problem evolve actually in large organizations, we'll go into a more tangible scenario where we'll define the problem statement using industry standard structure. Once we define the problem statement, we would need to develop a business solution blueprint. Now, this blueprint will have the entire solution to solve the problem that we have defined in the second part. Now, once the entire solution is developed, that's when we have an answer to the questions we are asking. And one of the answers to a specific question in that blueprint will result in a machine learning use case. So this is where a machine learning use case actually germinates. Now, in most cases, in most courses, when we talk about a machine learning use case, we directly jump to point number 4. But that's not so that doesn't really help us to understand how does the problem evolve actually in nature. But then once we have an understanding about the machine learning use case that the project will be solving, we'll start with the same process that we have learned in the previous section. So this is the second part of the module where we'll actually solve the machine learning project. So then we'll go into exploratory data analysis and feature engineering. We'll discuss about the approach required for the model development, evaluation, and optimization. And finally, once everything is done, we'll talk about storyboarding, the last part of any project, where we connect the dots and we kind of create a story that we can deliver to the stakeholder in a very layman way. So that's all for this module. I hope at the end of the module, you will have tangible experience in solving an end-to-end machine learning or any problem that arises which can be solved data-driven. So let's get started. So let's start with a simple overview for the project use case. Now, every machine learning project actually belongs to a larger story that follows the data science way. That is, it all starts with a question. Now, if you try to boil this down into a simpler objective, we can say it starts with a simple question: what happened? And once you understand what happened, it then follows by another question: why did it happen? And once you have more insights into these why questions, it eventually culminates into when, and so what, and now what. Now, the moment you have answers to why and you reach the part when, so what, now what, now this is where primarily machine learning problems are actually touch based. Now, I understand this is a very abstract way to understand the overview of the project. So let's get into something more tangible. Now, just a small add-on before we begin. So, the machine learning project which we talk about is not actually the origin of any problem. Now, the origin of any problem will actually start from right from the top of the leadership team. So let's say you belong to a large organization where you have several thousands of employees working for a common purpose. Now, the top leadership or the person who is responsible for the entire growth of the company might have some questions, and in that question, he finds something problematic. He finds a crisis. That's when actually a problem germinates. And while solving the problem or trying to understand why did this problem come into existence, that's when they uncover a couple of different reasons. They can uncover different factors or different reasons that contribute to actually this major crisis. And then, as a solution to circumvent that crisis, is when you try to reach and boil down to simple, specific problems. Now, when you talk about machine learning use cases actually belong to these specific problems that eventually solve the larger problem. So let's look at how we can actually understand this, the real problem. Now consider that you have a use case for a bank. So for a major retailing bank, the CEO asked, what happened? Now when he asked what happened, there's a team who would pull data, who would be aligned with strategy, they want to understand what happened. There's another team who is associated with business intelligence, data science. Now, business intelligence is already a part of data science, but then uh, eventually, when you try to ask a question, what happened? There are always these data guys who will try to give you an answer. And these answers are given out as basic numbers. Now, this would be a set of candidate answers the CEO might have actually received. So when he asked what happened, he would say, okay, fine. For this year, the profit has reduced by 30%, cash liquidity is down by 20%, fraud transactions increased by 5%, and overall operational expenses is now a concern because it is also increasing. So this is a candidate set of answers that a CEO would receive in response to a question framed by him. Now, this news is definitely not encouraging. There is definitely a concern that would pop up in his mind, and he would definitely try to see how we can circumvent the situation. So, to understand better what happened, the next follow-up question would be, why did it happen? Okay, you say that profit has reduced by 30%, but then why did it actually happen? You also see that cash liquidity is down, for transactions has increased. But are there any reasons that this has happened? The next question which follows up from that question would be, why did it happen? So you would have kind of answers like, let's say, okay, fine, we did an analysis, we explored the data, we tried to understand what reasons could actually contribute towards these issues, and we understand that the crisis over here has primarily happened because the investments from customers has reduced. The campaigns which we have been conducting has kind of a lower conversion rate, and overall, because of operational expenses been increasing, that has kind of affected the profit margins. So again, you have a larger understanding of what happened, and you have a fair amount of understanding why did it happen. But then the next question would be, okay, so you need to solve this problem. So the question would be, okay, fine, let's say, what do we do now? Or when will this situation again happen? Or a couple of questions, now what? So what? So these are a couple of questions that would follow up from here. Now, the moment the questions follow up from here, that would actually lead to a more specific use case. So, for example, let's say you understand investment from customers has reduced. Okay, now you understand investment from customers has reduced. So, what can we do to increase that? that would be a specific project. Campaign conversions have been low. So what could we do to actually increase the campaign conversions? That's a different project. So this is where projects become more specific. And one of these projects eventually culminates into a machine learning project. So, what could be a tangible follow-up over here? You understand when will it happen? That will give you visibility into the future. So, let's say you have seen a couple of fraud transactions happening over here, and you will also understand a couple of reasons why it has happened. Now, you will understand when will fraud happen again. So, let's say if you have visibility that in the next 6 months there are chances that around 14 to 15% of frauds are going to happen. That's an insight. So you can take more tangible actions to actually circumvent that, or you want to improve campaigns. When you want to improve campaigns, what you're doing over here is you're calling up customers and asking them to like subscribe for a deposit term or subscribe towards a package. You would need to understand what would be the propensity of a customer to actually subscribe or convert. Now, instead of targeting everyone, if you have an analysis tool that will help you to understand what is the propensity associated with each customer, and based on this understanding, you can select the best customers that could possibly be the best candidate set for your analysis. So that's a high level overview of how a problem trickles down from the top to the bottom approach. Now, if you take a wiser look at this, we can define this with simple terms. Now, the moment you have an activity that kind of primarily focuses to understand what happened, we associate that term as descriptive analysis. The moment you try to understand why did that event happen, that is basically when we do inquisitive analysis. Now, from inquisitive analysis, you might move to either predictive analytics or prescriptive analytics. Now, again, prescriptive analytics is not a separate branch. It includes predictive analytics within. It's actually a superset. You can say predictive analytics is a subset of prescriptive analytics. So let's just try to understand this with a simple example. So what happened? We would say profit has reduced by 30%. That's descriptive analysis. Why did it happen? It's primarily happening because investments from customers have reduced, operational expenses have increased, campaign conversions are low. Okay, so you're saying campaign conversions are low. Why did that happen? And when will it happen that a customer is going to convert? So you have 100 customers. You are trying to understand when will a customer subscribe to a package in the next 6 months. Do you have an answer to that? That's predictive analytics. You understand, okay, now what, so what? So you're leveraging futuristic data, you understand the situation, and based on that situation, you take a predictive outcome. So you're saying, okay, fine, campaign conversions are low. Okay, so with the current state of progress, how does the next 6 months look like? So you see that in the next 6 months, there's kind of a declining trend, and you kind of observe that overall campaign conversions are around 40%. In the next 6 months, it's going to decline to 20%. So you're leveraging the current state and you're focusing into the future, and then looking what's going to happen in that scenario. So that's not promising. So you say, okay, fine. What if I do X, Y, Z? What if I increase my staff by X percentage? So you're saying that currently in the campaigning and marketing team, we have around 50 team members. What if I increase that to 75? How will that impact look like? Now, with that new additional element, you'll try to check how does the future look like. So you're saying, okay, fine, with this increment, the future looks like, okay, there's going to be an effectiveness of approximately 20%. So you say, rather than 40% conversion, you can kind of expect around 60% conversion. And probably you might not be satisfied with that. So you can come back, try again, look into the future. So you're taking a prescriptive approach. That's when you say, okay, now what and so what. So this is a broader perspective of how actually projects involve or evolve in an organization. Now, most machine learning projects which we look into actually starts at this point. We essentially miss out at looking what happens before that. If we understand what happens before that, we actually get a broader perspective of the solution that we are trying to solve. So that's a high level overview for the project use case. Let's move on to define the problem statement. So let's move on to define the problem statement. Now, generally, when we talk about a framework or a structure or an approach to define the problem statement, most people are generally unaware that there exists any framework to actually help you define a problem statement. So, if you look into software development, or if you look into, if you have been playing games and you try to play war games, you can kind of get a blueprint of the warfare approach, the military approach. Let's say you're trying to build a building, so you have an architecture's view of how the building is supposed to look like. You have models to actually visualize your solution in the problem. So unfortunately, when you talk about problem solving, most people misunderstand that there exists an approach to define the problem statement. Now, we have been talking about the banking problem, where the CEO of the bank has actually understood that the profit has been declining over the period of time. Now, think about this scenario. You are a person who is trying to solve this problem, and you want to pass on this problem statement to somebody else. And if that new person who is completely unaware about the situation looks into that problem statement, reads it once, and gets complete understanding of the problem scenario. Now, that would need the problem to be defined in a structured way. So that's when we're coming to an approach or a strategy or a framework that will help us define the problem statement. Now, once we define this problem statement, and if you pass on this statement to somebody else who is not really aware about the problem statement, can read this and get complete understanding of what the actual problem is. So this framework is called SCQ, which stands for Situation, Complication, and Question. This is a widely accepted framework which evolved from the origins of McKinsey. It eventually made place into several consulting firms. Data analytics firms like New Sigma and a couple of others have an approach similar to the situation, complication, question. It's slightly more refined, so we are looking at a more generalized way of solving problems. Different companies have evolved their strategies and evolved their frameworks to suit their requirements better. We look at a generic approach, how we can define a problem. Now we are using the SCQ approach. Now the SCQ approach defines the problem by defining it across three segments. The first one is situation. So over here, first we define the situation. Situation actually leads to the current situation. So how does your current situation look like? Once you have defined the current situation, it will actually help and directly move to the end outcome. This is your desired future state. It's the way you understand this is you are right now on this problem, and your desired future state when you solve the problem should look like this. Now for your path to move from point A to point B, how does it look like? What can you do? So that's when we say you need to use or you have a roadblock. And that's a complication represented over here. So the complication is actually the hurdle that blocks your path from point A to point B, which is your current situation, to your future desired state. Now, what is this complication? It'll be followed up by a key question, and that question is represented over here. So generally, if you summarize this, we say that you have a current situation, you have to move to a desired future state. Now, to move from point A to point B, there's a complication, and to solve the complication, we have a key question. Now, this key question could be followed up with multiple sub-questions and so on. So let's try to fit our use case into this scenario. How does the framework support and detail our use case? Now, what is the current situation? So our current situation is profits for XYZ Bank has plummeted by 35%, cash liquidity has been declining, and operational expenses have been increasing year on year. Banks would like to study the major reasons for this crisis. So this is a situation. There is a crisis. They have been seeing declining profits, increasing operational expenses, and the cash liquidity has also been declining. What is that is required? What is the desired future state over here? So this is a crisis. How will the desired future state look like? Now, the desired future state will be actually the one without the complication. It would be XYZ Bank understands the various reasons that resulted in declining profits and the overall crisis. So that's the first part of the solution. Second part would be the team has a robust framework to counteract and resolve the crisis. So the first part would be you understand the problem, the reasons for the problem, the reasons for what actually helped in evolving the problem, and then you actually have a means to counterattack and solve the crisis. So that's the desired future state. Now, what stops you from moving from point A, that's a problematic situation, to your desired future state? The problem is the complication, which states the major factors that contribute towards the declining profits are not known. Fair enough. Now, how do we solve that? That's when we ask a simple question. So, what are the likely key factors that led to the financial crisis? Now, how do they impact the crisis? What actions would circumvent the impact of these factors? If we have answers to these questions, that essentially solves a problem. So this is the simplest way we can define a problem in a structured way. Now, if someone who is aware about the situation, complication, and question approach, you can actually pass on this slide to somebody else who is agnostic about the problem, and he can still be completely aware about the problem just by reading the slide. So this is the way leadership teams who would need to understand the problem with the minimum amount of words or within the minimum time frame. How do you get to understand the entire problem? That's the way we go ahead, the SCQ approach. Now, once we have the problem statement defined, we need to design the blueprint for the problem. So now we have a fair amount defined here. You have the current situation defined, you have the desired future state defined, you know the complication, and you know what questions you need to answer to resolve your complication. So we need to build a blueprint that will help you solve this problem in a structured way. Let's move on to understand how we can build the blueprint. Now that we have the problem statement clearly defined, let's have a look at the business solution blueprint. So developing the blueprint for the business solution is actually a structured process. Now we have a high level process structured and formulated into the simple flowchart. Now this might be fairly different in different organizations. Most organizations kind of tailor the process with respect to their requirement. But this is a high level generalized approach, which can be fairly adjusted in any environment. Let's understand the flow. The process begins by defining the problem statement. Now, this is a step which we have done in the previous slide with the help of SEQ. So we've understood the situation, complication, and the key question that needs to be answered, and then we have clearly defined what is the problem statement. Now, once you have the problem statement defined, the next step is to delineate the problem statement. Now, this is a process which involves team brainstorming. So a bunch of guys to sit together with a common shared goal of solving the problem. Now, a team is actually important over here because you need diversified inputs rather than a biased input. The moment you have a team together, the brainstorming process becomes more healthy. Now, this is done using a simple factor map. We'll get into the details and I'll show you a basic factor map in the next slide. But for now, just assume that factor map is a way to organize your random thoughts into a structure. So let's say you have the problem statement defined and you're trying to understand what are the different factors that will help you to that kind of affect the problem. You're trying to understand what are the different factors. So you randomly sit and you start discussing different topics. But till this point of time, you don't really have data with you. So this is a data agnostic approach at this point of time. You sit in a room as a team, you try to understand what could be different factors that that are associated with this problem and that definitely have an impact with this problem. So that's when we create the factor map. Now once you create the factor map, the next step would be to design the hypothesis-driven matrix. So each factor that you identify in the previous step will have an associated hypothesis. Hypothesis could be in a negative way or a positive way. So for example, let's say one of the factors that you believe that has been a problem is, let's say, customer churn. So your hypothesis associated with this factor would be an increasing customer attrition has resulted in declining profits. That hypothesis. That is the hypothesis. So this hypothesis could be a true one, could be a negative one. Irrespective of that, that's an insight. So you could use data to understand whether your hypothesis is true. If it's true, great. If it's false, that's a counterintuitive insight. Now, once you have the hypothesis-driven matrix, which is a collection of all the factors and their associated hypotheses in a structured way, you move on to actually solve the problem in a tangible fashion. So you know what exactly is your problem statement. You have fairly a high level understanding of the different factors that you have, that you believe are a part of the problem. You have an associated hypothesis which with each one of them. And now you move on to understand how you can acquire data to solve the problem. So this is where the data-driven approach begins. Machine learning problems kind of originate just one step before this. Like you have a hypothesis that could be a specific problem, and one specific problem can actually lead to a machine learning solution. Or it can come later when you're talking about key action items. We'll talk about this in a while. The next step would be to solve the problem data acquisition. Once you have the data acquisition done, you'll go on to understand EDA. Like you'll understand the data better. So you'll do exploratory data analysis, you'll do hypothesis testing, and you'll have an answer for each of the hypotheses that you had defined in the previous step. Now, when you have all the answers for all the questions that you have asked, the next step would be assimilating all the insights and defining key action items. So once you have all the insights neatly aligned together, you would define, okay, fine, with this current scenario and these problems impacting the problem, these factors impacting the problem in such a way, we understand that the key action items would be first to increase something, which means which would eventually lead to like, okay, develop a machine learning product for that, or reduce a problem's impact. So that will be there'll be some strategic realignment, or improve CSAT, customer satisfaction. There'll be an associated outcome with that. So there'll be like an endless list of action items and different priorities that would come after you assimilate the insights. So let's take it more tangibly. You define the problem statement. You have the SAQ already done. You delineate the problem and you do a team brainstorming activity to come up with a factor map. Let's look at what would you understand by a factor map. Factor map is, in a nutshell, a simple process to have a structured brainstorming exercise documented on paper. So how would this go ahead? This would be connected with the SEQ. So if you remember in the previous slide, we talked about SEQ, where we have asked, okay, fine, this is the complication, and what are the key questions that need answers to move ahead? So the key question over here is, what are the key factors that led to the financial crisis? Now, this is where the team starts and begins solving the problem. So in the factor map, we start identifying what are the key factors that led to the financial crisis. Now, there could be an endless list of factors that could possibly be associated or not associated. But then when you move ahead with this approach, you have to be first data agnostic. You don't really have to make any assumptions about the data. That even whether you will have the data, that's a different thing. So let's look at a basic factor map and a hypothesis matrix. So here, this is a sample factor map, and this is by no means an exhaustive factor map, but this is just representative of the one I would believe you should create for your problem statement. So the factor map starts with the key question. What are the key factors that led to the financial crisis? Now, there will be several factors that you could think about. When you sit together as a team and you try to build an exhaustive connected map, it could be a structured, layered approach. Let's say, so this is a very simple one. You believe that fraud transactions have increased, right? So the number of fraud transactions could actually be a problem. Customer churn could be a problem. Macroeconomic factors, customer service, which could be poor or good, marketing campaigns, which are not really effective right now, and the overall brand image. Is there a tarnished brand value? How do people perceive your brand? All of these factors could actually lead to your declining profits. Now, if you look at a more realistic version of a factor map, that would be an outcome from a brainstorming exercise within a team. It's going to be really complex and really exhaustive. This is just a miniature version of the factor map I wanted to showcase to you so that you could actually design one for your problem. Now, a real one would actually have several factors under each of these factors. So you have customer as a dimension, and within customer, you'll have customer related attributes, and you would believe that all of these attributes in some way impact the kind of outcome we have over here. So on. So this is how you would actually whiteboard and document a brainstorming exercise, which you believe that would be one of the reasons for solving the problem. Now, once you have the entire factor map documented, each of these factors would have an associated hypothesis. So you create the hypothesis-driven matrix. This is a step which follows right after factor map. So if I go back to the business solution blueprint, We define the problem, we delineate the problem statement, that is, we use team brainstorming with the factor map. Once you have the factor map, we design the hypothesis-driven matrix. Now, in the hypothesis-driven matrix, we create an entry for each of the factors we believe are a part of the problem. So I've just showcased a few to enlist how it looks like. So let's say one of the factors were customer churn. So your associated hypothesis would be higher customer churn has resulted in declining profits. Now, what is your observation for that? Observation will come in once you have data and you look into the data and you do exploratory data analysis. So this column over here would be filled only after the next step when we do data analysis, after data acquisition, and then followed by EDA and hypothesis testing. A couple of other macroeconomic factors would be like, okay, Brexit and GST has resulted in declining profits. So you would like to see the kind of profit trends before GST, after GST, before Brexit, after Brexit, and so on. Customer service could also be another factor. So poor customer service has resulted in customer attrition and hence declining profits and so on. So there'll be a long list of all factors over here and your associated hypothesis over here. Now, once you have all your thoughts documented neatly over here, the ideal next step would be to actually go ahead and test them. So that's when you go and acquire data, um, test your hypothesis, do some exploratory data analysis, and fill in the observations over here. Some of them might be true, some of them might be false. So, for example, let's say you believe that high customer churn has resulted in declining profits, and you believe this is one of the most fundamental factors that has affected your problem, which is declining profits. But when you look into your data set and you try to do some analysis, you don't see a trend that kind of works in synchrony, in harmony with this hypothesis. So this observation might be false, that this is not the case. So when it's false, that's also a counterintuitive insight. The next one would be, let's say, this macroeconomic factors. And you believe that macroeconomic factors did have an impact on the end outcome, that is, declining profits. When you look at the data, you do some analysis, and you do see that. So that would be a yes. This would be a true hypothesis. So when you follow this fashion for several different hypotheses, you have a matrix where you have documented the validity of each hypothesis, and you have neatly organized the impact of each of these hypotheses. Now, in a nutshell, you could actually use this as a key answer sheet, assimilate your understandings and the insights combined together, and kind of find a solution to your problem. So this is where we go back to the same question exercise. You start with the question, what happened? You try to understand why did it happen, and then understand when did it happen again, or now what, so what. So this part, the factor map and the hypothesis-driven matrix together combine and give you answers to why did it happen, right? We have still not reached now what, so what, or when will it happen. We're still in the inquisitive phase. So coming back over here, we move on from defining the problem to understanding the factor map, designing the hypothesis matrix, acquiring data, performing EDA and hypothesis testing. And once we have all answers neatly documented, we would assimilate the insights and define key action items. So once you have clear understanding, okay, fine, each of your hypotheses is either true or false. Whenever an hypothesis is true, that will have a certain associated action item. Whenever a hypothesis is false, that would also have certain action items. So let's say based on some understanding you saw in your hypothesis-driven matrix, you understand that customer satisfaction has been decreasing, and that is the reason for declining profits. So one of the key action items would be increase customer satisfaction. And how would you do that? It could be through developing a machine learning algorithm, which would result in a chatbot. I'm just giving a random example. So let's say the designed outcome would be, okay, fine, customer satisfaction is decreasing because of poor customer service. So one of your ideas would be, okay, fine, to serve the customers better, you would take everything digital and provide a chatbot through which the customer can interact and get instant answers. So that would be a tangible outcome. So this would become eventually one machine learning use case. Now, some action items will not necessarily require machine learning as an outcome. So let's say you're saying, okay, fine, reduce operational expenses. So that's like reduce XYZ probably. And that will become, okay, you need to have strategic realignment as a solution. Something like that. So in this fashion, your key action items will have a list of priorities, actions, and the outcomes expected from those actions as a solution path. So all of this together kind of summarizes the blueprint for your solution. So you define, delineate, design, then perform, assimilate, and finally define key action items. But once you solve all of this, you kind of believe that your problem is going to be solved. So till this point, what we have looked into is we have gently studied what happens necessarily before even a machine learning project is born. So tomorrow, let's say you're talking about a machine learning use case where you're trying to predict customer churn. So your end goal is to predict whether a customer is going to leave your bank and go to somebody else. That's the prediction you're doing. It's a classification algorithm. So that algorithm will have some history, that use case will have some history, that why are we even trying to solve this problem? So this blueprint is a means to understand the history of how did we arrive at the problem. The most use cases that I have seen available over the internet or taught in any courses kind of tend to avoid this business impact. And that's really a wrong approach. When you're talking about solving a machine learning problem, even though we have not delved deeper into each of these steps, it's kind of important to understand how does problem solving work in any industry, and specifically when you're solving a machine learning problem. So that's the basics the of developing a business solutions blueprint. We have looked into the different processes. We have studied the factor map as well as the hypothesis matrix. And we have finally reached the point where a machine learning use case germinates. So in the next step, now that we have defined the problem and reached to a tangible outcome, let's look into a specific use case for a machine learning project. So let's start with an actual machine learning use case. This will be the second section of this module. In the first section, we kind of looked at a high level that how does an actual machine learning use case evolve, or how does it germinate? What's the history behind that? We took some business context. We looked into a high level scenario that how would actually an organization approach a problem and reach to a point where actually machine learning use case comes into the picture. So now that we've done that, we are now coming to a scenario where we start defining a specific problem. Now, till that point, we're talking about aggregated problems. We've reached the point we're talking about a specific problem. So this is the problem statement that I have framed for this project. So a leading bank, which we have been talking about so long in this module, has seen decline in profits year on year. The team has studied the various factors that contribute towards the decline and understand that lower campaign performance from the term deposits. So if you look at the problem we have framed currently, and if you tie this to your previous solution, you can actually understand that, okay, you have a bank, the CEO of the bank has asked a question. And in response to that question, we have received an answer saying that the profits have been declined. That puzzled the CEO, and he followed up with the question saying, why did it happen? And you performed all of these strategies, you developed a factor map, you conducted hypothesis testing, and then after all of that, you understand that the primary objective, or the primary factor, sorry, not the objective, primary factor that has contributed towards declining profits is the marketing team is not doing a good job. So the marketing team is not doing a good job because term deposits, which kind of bring customers money into the bank as deposits, and customers are rewarded with a specific interest rate. Now that's how the bank makes money for other projects. They invest that and then make profits on that, and then the cycle continues. So what they've seen is the marketing team is not really doing a good job. The kind of campaign they're doing, conversion rates are pretty low, and because of lower conversion rates, the kind of subscription towards term deposits is decreasing, and that has eventually led to lower profits. So this is the context for the problem, and your solution would be you have to develop a machine learning tool by leveraging historical campaign results and customer data to predict the propensity of a customer to successfully subscribe for a term deposit with the bank. So technically, you're developing a classification supervised machine learning algorithm that will predict the propensity of a customer to subscribe to a term deposit or not. So technically, the process would be there's a marketing team who will be making cold calls or campaigns where a customer is targeted by some other means. It could be a phone call, it could be emails, it could be messaging, something like that. And customers ask, okay, are you interested in starting a term deposit with our bank? This is the offer we have, and so on. And the customer might say, okay, yes, I'm interested, or would say, no, I'm not really interested. So if you look and study into the historical data and you develop a machine learning algorithm that leverages this machine learning, that leverages the historical data and predicts the propensity of each customer in a scenario, you would have literally access to the future. So technically, if the marketing team is given this tool, what they would do is, let's say they have a customer base of 100 million customers, and they plan to target these customers over a period of time. What they would do is, they would use this tool and understand the propensity of each customer. Once they understand the propensity of each customer, they would only select those customers who have a higher propensity for associating a short-term deposit. So let's say if they have studied using the historical data of a couple of customers, quite a few customers, now they'll use that the machine learning algorithm which has been developed using this historical data and predict the outcome that would be expected on a couple of customers under different situations. So when they do this, they understand, okay, fine, out of 100 million, only 15 million customers are actually having a high propensity to convert. So rather than focusing on all 100 million customers, the marketing team would actually improvise their efforts in targeting only these 15% or 15 million customers. And out of these 15 million customers, they would kind of expect to target and convert most of them. Now, in such scenario, you would end up in reducing the effort put in by the marketing team, and you would also expect a higher conversion rate. So that's the context for the machine learning use case. Let me just paraphrase. A leading banking giant has seen declining profits. The team has studied various factors that contribute towards the declining profit, and they understand the lower campaign conversion rates for short-term deposits is the main reason. Your objective would be to develop a machine learning algorithm that will predict the propensity of a customer who to subscribe to a term deposit. Now, if you remember in module 3, when we're talking about a high level part of exploratory data analysis, we said that we normally start with the machine learning use case where we identify the problem. We move on to gathering data, performing EDA, building machine learning models, evaluating them, and finally productionizing them. So this is the same approach which we had referenced in module 3. So for this use case, I'll point you to a data source which is available under the UCL machine learning repository, the same repository from which we took and accessed the bike sharing dataset. So this is a link which will help you download the dataset. Now, if I'll point you to the data source right away. So here we go. This is the dataset. It's available under the link which I have pasted in the slide. You can go over here, or you can just say UCL machine learning repository dataset for bank marketing. Now, this is a dummy dataset for our use case. I'm just trying to fit the use case into our story. You'll have the attribute information and datasets. I would ask you to please download the dataset. Now, within this dataset, there are 4 different files available. There's one which is actually mentioned as bank additional full.csv. Now, this is the dataset that I would recommend you to start using for the use case. Let's get back to our slide. Now, we are at the third stage or second stage. We have done the second stage. We have identified the problem, we have gathered the data, and the next step in this process, before we start developing models, would be to understand the data and build features. That's essentially performing EDA and feature engineering. So if you tie this entire process to the previous slides, we are talking about a situation which has flown through all these steps and has reached a specific problem. So from a generalized problem, you move ahead, define your process, and understand key outcomes, and then define a key tangible outcome or a specific problem for the solution. And each of these might take course as a new project. Some of them might be a machine learning problem. Some of them might not be a machine learning problem. Now we are looking at one specific problem. So let's say we're trying to understand increase campaign effectiveness. Let's say one of them is increasing campaign effectiveness. And the solution for that would be developing a machine learning product. So that is what we have tied over here as a use case, which you can clearly see a simple tool for the marketing team. And if you go back to the same use case approach, which we have studied in Module 3, we should now ideally start with performing EDA and building features. Now, this at this point, I would actually just give you a high-level approach, what kind of areas to dig deeper into, and what features probably you could build. I'll just give you a basic overview, and I would expect you to actually uh, delve into the data, ingest, understand, and study the data, build features, refine the data, and then move on to building machine learning models, and then probably we can talk about productionizing solution later on. But then, in the next section, I'll talk about a couple of things which would be necessary for you to actually get started with EDA. So let's move on. So let's begin the exploratory data analysis and feature engineering. Now, for the Capstone project, I wouldn't, however, be doing the coding for EDA and feature engineering. It would be expected that you would code on your own and complete the project. In this section, the objective of the session is to actually give you a basic approach, a couple of refreshers of what needs to be done, and what kind of probably what are the different approaches that you could take, what alternatives exist, and at a high level, you're kind of defining the approach that you would need to adopt to move on from EDA feature engineering to actual machine learning development. So let's get started. I'll just show you a brief overview. I'm importing the data. This I would recommend you to actually start with the data that mentions as bank additional full CSV from the same source. This has the exhaustive list of customers with all the attributes required. Now, as we already know, we start with the simple step. We say df.shape, and we see around 40,000 rows and 21 columns. So let's say df.columns, and you can understand we have data at a customer level. So we have the customer's age, the kind of job, his marital status, education, default, whether he has defaulted in a loan previously. Housing and loan would actually indicate whether he has a housing loan, whether he has a personal loan. Probably contact defines the number of times he's been contacted, month, day of week, would actually be the descriptive attributes like what month and what day of week has he been contacted, and a couple of other numeric variables like number of employees at that point of contact, and probably a couple of terms which is kind of not clear here. So this is just a basic overview by looking at the column names, and I presume this would be the y variable, which is the outcome, whether he has converted or not. Now, to understand better these columns, what we would do is we'll say first df dot d types. That will give us the data types, and you can see a couple of them are object, which means categorical, and remaining a couple of them are actually numeric. This gives us kind of a better idea of what the columns look like. Let's just say df.head, and we look at the first three rows in the data set. So how does it look? Age is a gendered number, job is the kind of job he has, housemaid, services, etc. Marital status will have values like married and so on. Education would be high school, basic, etc. Default is yes, no, and probably even unknown. Housing is yes or no, it's a flag. Loan again would be yes or no. Contact is the means used to actually contact the person, and so on. And this is the end outcome variable that will be required to model. Now, for additional information on all of these other columns, you could actually leverage the data description available in the same link which I have provided. So if you open up the same link, over here, you will have attribute information. So you can see, okay, 21th column, Y, has the outcome that the client has subscribed a term deposit. It's a binary number value which has values like yes and no. The number of employees at that point of time, Euribor 3-month rate. I'm not really sure what this means. We would need additional research over here. Consumer confidence index, consumer price index, employment variation rate. Now, these are terms associated more with the banking domain. If you are new to the banking domain, it's highly advisable to actually understand the impact of these three different variables on the kind of outcome you're looking at. When we're looking at P outcome, the outcomes of previous marketing campaign, which is a failure, non-existent, or success. So if the customer is previously contacted, what is the outcome? Was it a successful outcome, failure, or he was never contacted previously? Then the number of days. So if you look at a high level, we have attributes of the customer, of his relationship with the bank, like whether he has a housing loan, personal loan, that he has defaulted. We have information about the previous campaigns, like how many times he's been contacted previously. We have a couple of microeconomic factors which are related to the banking industry, and we have his end outcome. So overall, we have a rich set of attributes that help us define the problem. So let's get back to the next step. So if you study these attributes clearly, you will actually get a more high-level understanding of what is your data telling. Now, after this, which is what is the right next step? So if you remember from module 3, the first step which we need to take after ingesting data or after understanding the data's length and breadth is univariate analysis. So I'm not going to code and actually showcase each of the analysis outcomes for univariate, but then essentially what you would do is you would consider two separate categories, numerical columns and categorical columns, and look at what does each of these attribute talk. Once you finish univariate analysis for numeric as well as continuous attributes, the next step is ideally to move on to bivariate analysis. So when you're talking about bivariate analysis, you have a simple outcome, which is yes or no, and you would actually understand the impact of any one of these variables on the outcome. So for example, let's say you want to understand what is the conversion rate of people of different education. So the hypothesis would be, okay, people of high school will have more conversion rate, people of basic education will have lower conversion rate. Now, when you study the impact of different bivariate studies, like age across the outcome, campaign across the outcome, and so on, this will help you to understand kind of at a high level what is the impact of each of these individual columns on the actual outcome. Again, one point over here, when you're doing bivariate analysis, again you have two different scenarios. You would have a categorical variable and a numeric variable. So over here, in this scenario, the binary variable which you have over here is actually an object. So it is a simple yes or no. So if you're doing simple binary outcomes, it might not really be straightforward for you. You will need to convert this to a flag or a numeric outcome. So you can use a simple if else condition and convert this, or you can use the binary, you can use a label encoder, a package available under sklearn. I'll just show that illustration and I'll show you one example how we can go forward. So let's say from sklearn dot preprocessing, we import label encoder. Now let's say we say LE is equal to label encoder. We instantiate an object and we will say df dot y new, which is the modified y, is given as le dot fit transform, and we pass the previous column, that is df y. And if you look at the output now, let's say I will say df, let's do a head command. Now if you look, we have yes and no associated as 0 and 1. So this is now a numeric outcome. Now if you want to do a simple bivariate analysis across two different objects, you can actually build, you can actually study the relationship using the different plots like bar charts, stack column charts, which we learned while exploring module 3. Let's take, so coming back to the topic, we have different plots to understand the kind of impact of one independent variable on an outcome variable. So if you want to simply do a basic check on how does your bivariate analysis work now. You can say you can study the outcome of default, whether whenever the person has defaulted, what was the actual impact on your outcome variable. So you'll see a variation. Okay, fine. Whenever the default was yes, there's a higher or there's a lower conversion rate. The defaulting was no, there's a higher conversion rate. And when the default was unknown, it was a moderate conversion rate. So these are the different techniques you can use to actually perform bivariate analysis. So at a high level, you would use the same steps which we studied while exploring univariate analysis, bivariate analysis, and complete your basic understanding about the data. Now, the next step would ideally be to, once you have finished understanding univariate and bivariate analysis, the next step would actually be to go ahead and complete feature engineering. Now, feature engineering, it's best with domain knowledge, since you would actually be missing some banking context or BFSI domain context over here. The general approach to acquire basic information about the industry would be just try to understand how does the different variables mentioned over here, consumer pricing index, consumer confidence index, Euribor Express, all of these different variables, how are they associated with the banking industry and what kind of impact do they have? And you can just try Googling basics about the industry and you can understand what is the kind of impact of these variables on your end outcome variable. You would also need to do outlier treatment because I'm sure a couple of these numeric variables will definitely have outliers. And not just numeric variables, categorical variables will also need treatment. So as a part of feature engineering, there might be a need to actually reduce the number of levels in one of these categories. So over here, the structure looks straightforward, but then if you look at job, I'm kind of sure that the number of values that come on the job, let's have a look at it. So we'll say df, and we'll say job, let's say value counts. So if you look over here, we have a lot of different values over here, and most of them kind of come into admin, a huge chunk under blue collar, technician, and the number keeps tripping. So even though these number of distinct rows is not really very big, let's say then the total number would be something around 15. But then if you kind of reduce that to a certain level. Now, the first thing would be you study them and you see whether there's an impact. What is the kind of impact across all of these attributes? Now, these top five would actually be the biggest chunk, and the remaining will have kind of smaller impact. Unless you see something really interesting over here. So, something interesting would be okay, unemployed, and when you have unemployed, you have around 1,000 people in that domain, and you see the conversion rate is zero, and the conversion rate across all of the levels is kind of at least 25 to 30%. But then something over here is extremely unusual. So that would be mean okay, fine, you can actually consider separately. You can't combine this with others. So what I'd say, as an act to reduce the number of levels, let's say the top five as they are, the next 4 5 as just a single unit as others. You'll keep one of them as separate if in case it's interesting, something like that. And at the end, let's say you have 5 or 6 distinct values over here, you're kind of reducing the noise in that categorical column. But this again requires a bit of judgment and that needs iterations. So feature engineering also comes in formats of transforming the numeric variables. So I see number of employees, and if I'm not wrong, number of employees. This would indicate the number of employees in the bank at that point of marketing campaign. So this would roughly convert to a number which is not having a lot of variations. So let's say the company is having around 5,000 employees, the numbers kind of increase between 100 more or 100 less. You won't see a lot of variation. So rather than keeping this as a number as it is, you could use the scaling standard scaler, and you could actually normalize or standardize these numbers. That will have a better impact. Same, if let's say there's an impact from what you call, let's say if some values don't have any variations, you could actually drop that column, or actually you could use a standard scaler or normalizing star process to actually go forward. So that's the basics about EDA and and feature engineering. I've just discussed a basic kind of approaches that you could take forward to implement in this project. the actual outcomes from feature engineering is an endless list. You really don't have a structured way to understand what are the most appropriate ways to go ahead with feature engineering. Now, the more you research and understand, the better approach you will have to understand the data and develop features. So that's just the basic overview about this process. I would recommend that you get started with this process with a lot of diligence, explore the data. You might actually get frustrated in the process because it's an iterative process. But then please don't leave any corners like any corners to while in the process of understanding the data. It's an iterative process. It takes time. And honestly, feature engineering and EDA is the time where you spend majority of your bandwidth in any machine learning project. The next steps are less effortsome. You don't really spend a lot of time over there. Significant part of your time is actually spent in cleaning, processing, understanding, and augmenting the data sets. Now you will have to use all those visualization techniques in conjunction with univariate bivariate analysis so that you can actually do better feature engineering. Uh, the entire visualization process is incomplete in the EDA. It will only help you to understand the data in a much better way. So please don't miss out on creating plots, a variety of different plots. You can try combinations of bar charts, star bar charts, explore what are the different techniques available within Matplotlib, and then leverage all of them to reach to a conclusion for EDA and EDA and feature engineering. So that's about this. We move on to the next topic. So before you watch the next video, I presume that you would have already practiced a lot on ED, and you would have tangible outcomes. Because in the next video, I'll be talking about what kind of challenges you would expect to face in the machine learning development for this particular module. So before moving on to the next topic, I would highly recommend all of you to first finish the EDA and feature engineering process and only then move on to that topic. Else the topic will actually be not much value. So that's it. I'll meet you after EDA and feature engineering in your project. Let us now look into the approach for model development, evaluation, and optimization. So at this point of time, I presume that you have already explored EDA and feature engineering on the data set. You are probably very comfortable with Python now, and it's just one step before understanding what needs to be done before building a module. So if in case you face a couple of issues with the syntax and getting the plots right, that's fine. It's an iterative process, and it actually takes a while to get accustomed to the syntax nature for Python. So keeping aside all those trivial issues, I'll focus on a couple of roadblocks that you might face while developing machine learning models. So let's look at the dataset once again. Now, there's a specific reason I chose this dataset, and you would have probably noticed that by now. So if you look into the dataset, it's kind of very straightforward that this is a very unbalanced dataset. When I'm saying unbalanced, let's look at the outcome variable y. And if we do a simple value counts, we get a distribution of data points across these different values. Now you can see over here, we have two distinct values, no and yes. And out of 40,000, approximately 36,000 is no. 4,600 is approximately yes. Is yes. If you do the math mentally, this kind of is a 90% and 10% division. So only 10% of the data set is actually yes, and 90% is actually no. Now, when you have such an unbalanced data set, there are a couple of roadblocks that you would face in developing models with good accuracy. Now, when we talk about accuracy, it's also important to understand what would be a number, say, which would identify as a good number. So let's say if I give you a number saying that, okay, 89% accuracy is what we achieve with this model. Now, what would be your understanding? Is it a good model or is it a bad model? Now, if you generally talk about 89%, that sounds like quite good number, right? But then if you compare that number with this specific use case, it's an absolutely useless number. I know you will be stunned, but then let's look at why. So you would understand the accuracy of a model can be compared with the baseline. And this baseline will essentially help you understand how good is your model accuracy. So in this scenario, what is the baseline? Now, baseline can be a number which is defined as a score that can be got achieved without any efforts. So let's say in this scenario, if you have no efforts invested, that is, you built no model, you just have a model that predicts every outcome as no, right? So what happens in that scenario? You will have scenarios where you're saying no would be everything is no. So you let's out of 40,000 data points, 36,000 speculative no, and they're correct. Only 4,000 of them would actually be incorrect classification, which means that you by default correct 90% of them correctly, and remaining 10% are predicted incorrectly. But then the 10% you're predicting incorrectly, that's more important to you, right? So if you look at the overall accuracy, you're getting a score of 90%. That will not really make sense. So over here, a model will be more appropriate or more accurate only if it shoots up above 90%. So that's a very aggressive target. Now, is that the case always? Not necessarily. Now, it completely depends on the business scenario you have. But then if you look at a scenario where you have an unbalanced data set, it's kind of a call you would take in association with the business. So for you or in this scenario, it's more important to correctly predict a yes than no. So if in case of you build an approach where you're trying to improve the accuracy of yes, and you're kind of getting a tarnished value or no, that would still be fine in some cases as long as you don't have a bigger compromise. Because the moment you try to improve the accuracy for yes, kind of you see that the accuracy for no will actually decrease. Let's try to look at this from using a simple Excel based. I'll open up Excel and let's try to understand how we can uh, like explain this better using a simple confusion matrix. So let's say we move on to a simple chart where we'll have let's say we're building a confusion matrix. So we have a confusion matrix. We have 0 and 1, and then we have another 0 and 1. This would indicate the predicted values, and this would be the actual values. I'll just make it a little neater so that you can actually get the numbers digested easily. Alright, now this looks better. Let's just color code them also so that distinguishing them becomes easier. Alright, so in general, we'll have the total number of, so this will be a true, so this will be in nutshell, this will be the false positive, this will be the true positive, this will be true negative, and this will be false negative, right? Now, if you look at the overall accuracy will be true positive plus true negative divided by sum of all of them, right? But then you won't essentially see great results. You won't really interpret that as a great number, even if you have high overall accuracy. For you, the most important part is the true positive rate, or true positive should be higher. Now, whenever you try to increase true positiveness, true negative rate will kind of differ. Now, if in case you're not recollecting it, true positive rate can be defined as, let's say from all the ones which you have, from all the actual true positives, which will be, let's say, GP and false negative. This, my apologies over here. This would indicate the total number of positives that you would actually predict as one. But then this number doesn't have significance. You're looking at the universe, which would be the false positives plus true positives. Now, out of these, how many of them are correct? Now, if you try to get a couple of simple numbers in this place, this would look like, so let's say we have 85 over here and 5 over here. So which means that out of the 90, assume that we have 100 samples. So 100 samples, we have 90 as no and 10 as yes. Now this 90 will be converged as 85 and 5 over here, and let's say out of 10 we'll have 2 over here and 8 over here. Just assume this is a use case. Now what will be the overall accuracy? Overall accuracy will be 85 plus 2, that's 87. 87% accuracy. Is it a good number? If you just look at the number, it kind of seems okay. But then if you look over here, out of 10, out of the actual 10 now positives, you've only correctly predicted 2. So your true positive rate will actually be defined as 2 by 10, that is 20%, and that's really bad. Now you would need to actually improve this rather than this one. Now, now how do you go ahead with such an imbalanced data set? Now what happens is generally when you try to improve this, you'll see this one actually getting reduced more. So another scenario would be, let's say when you have slightly improved results, let's say out of instead of 2, you would have 5 correct over here and 3 incorrect. And this would be, let's say, 75 and this would be 50. So kind of compromising with 0, but then you're getting a better accuracy with 1. That's a scenario or a hurdle that you will face in this use case. So how do you actually circumvent that? Or let's say, how do you actually improve this to a higher level? Now, the first thing which you can do is when you have an unbalanced data set. So in nature, if you have an unbalanced data set and you train your model with an unbalanced data set, you actually get an unbalanced result. This is a classic example of unbalanced results. You're predicting one class really well and the other class horribly. So to actually balance your predictions, you actually need to provide a balanced data set. So what happens over here is, now if you look at the training data set, let's say if you have total 100 samples, out of 100 samples, you'll create a training set of 70 samples, and then you'll create a test data set of 30 samples, right? This is the general approach you would take, assuming you're not cross-validating, you're just using a simple test train. Now, out of the 70, if you look, around 90% of this would be a no. And the remaining 10% will actually be a yes, right? So this will be the split for a yes and no. And if you train this data set with such a skewed sample, it's kind of going to have an unbalanced prediction also. Now, what I would recommend is, if in case you're facing an issue, the best way over here is, instead of providing the same data set, which is 70 for training, you first balance this data set. Now, how do you balance this data set? What you'll do is, instead of passing 63 no and 7 yes, you'd actually say, you randomly select any 7 out of these 63. So this 63 represents yes, so this represents no, and this would represent yes. Instead of taking the entire part of 63, you'll take just, let's say, 7 and the entire of this 7. So you'll have around 14 total, as 14 data points for training. Now, the advantage of having such a balanced data set would be, your training is going to be fairly balanced. So what happens is your model learns to predict 0 and 1 with equal weightage, right? So what happens as an outcome of this would be, your false positives will reduce and your true positives will increase. A great thing. That is exactly what you want. You want your true positives to increase more. But when you move on to a balanced sample from an unbalanced sample, it's highly possible that your true negatives will reduce and your false negatives will increase. So to a certain extent that's possible, but then if it crosses beyond a limit, you'll actually see your overall accuracy kind of getting tarnished. So you can actually go ahead and resample this. So let's say you will take, let's say out of 63, you'll take 14 directly, and random 14, and this 7 you duplicate it and you take 14. So you duplicate that twice and you take 14. That's another way to actually go ahead and use. So whenever you have an unbalanced sample, you will use a counter method by either oversampling or undersampling. Oversampling is a technique where you oversample the unbalanced class. So in this case, yes is an unbalanced class with 7 values, 7% values. So you will oversample that and match it with the actual number. Another example would be, let's say you oversample it to such an extent that you'll have 63 values over here and 63 values over here. And 63 with over here would actually indicate 9 times duplication of this value. So kind of matching. This is oversampling. Undersampling is the prior scenario, where we'll say we have 7 from this and 7 from this. So both have pros and cons. I would recommend you to actually go ahead and explore what are the pros and cons associated with oversampling, undersampling, different methods of sampling, and try to see what kind of confusion matrix you get, and along with that you see what kind of true positive rates you get. Now, another question would be, what model would I actually need to get started with? majority of the crowd kind of assumes that why don't I directly code an ensemble model? And they directly start coding for a random forest or executing algorithm. That's kind of the incorrect way. I mean, there's no clear way of going ahead, but then the recommended approach would be you start with the basic white box model, something like logistic regression. Then you move on to a more advanced model after a couple of iterations. When you see you don't get really great results with logistic regression, that's when you move on to decision trees and then probably to another advanced algorithm like random forest or XGBoosting based on the kind of results you would see over here. But then, given so one thing is for sure, given that the data is unbalanced, you are definitely going to face this hurdle. And to remove this hurdle, you have to go ahead and balance the trading data set. There are a couple of alternatives associated where you can achieve this with the code itself by just changing a parameter. So if you're using random forest kind of provides you a hyperparameter called class weight. And you can assign a class weight that, like you can give a higher weight to the unbalanced class. So random forest while training kind of assigns that parameter and you get fairly balanced results. That's one way to actually achieve that. There's several other ways. I would recommend you to please explore how can we create a balanced data set for training in Python. Develop those models, evaluate them, whether you're getting a good true positive rate, what is a true negative rate. Try and see how are they changing the different outcomes, and then eventually optimize that. So this was just one of the roadblocks that I found interesting, and I thought I should share with you because you might definitely get stuck with this. But apart from that, you'll definitely come across a couple of other challenges. Probably a couple of variables might not be really important. One thing which we didn't discuss on this course was feature importance. There are a couple of techniques available within Python where you can just run a model with blindly and try to understand which feature is more impactful. And that will give you results in that, okay, out of the 10 features that you have used for this model, this is the associated importance in the descending order. So you can just remove a couple of columns, add a couple of columns based on the kind of importance that you see are more valid. So that's the kind of approach I would recommend you to take for model development, evaluation, and optimization. Happy coding and happy machine learning exercises. We meet in the next part, which is the last part of this module, storybuilding. Finally, we have reached the last section of this module, storyboarding. So storyboarding is an event organized at the end of every project when you actually showcase your results to the end stakeholder. Now, let's say if you're talking about a specific problem, like we have solved for a machine learning use case. Now, in this scenario, just with a specific problem would be showcasing the results of machine learning model, how does it look like, and how does it solve the larger problem. Now, when you're looking at a larger problem, like for our use case, we were talking about the banking problem, which where the CEO asked a question and the result was, okay, there was a 20% decline in profit levels. So when you try to storyboard, you have to incorporate the entire story in a simple logical way. The story would actually be analogous to the approach which we have taken. It's kind of cementing our understanding about the entire exercise. So if you go back to the first slide over here, yes, this is a solution blueprint. So storyboarding is actually taking into account in a more logical way and a simplified layman terms what is the problem, how did we define the problem. So over here we kind of refine the outcomes. We'll say that let's say if we have 100 factors, we won't talk about all the 100 factors. We'll say that these are the important factors that kind of aroused from the brainstorming session, and then we built a hypothesis matrix, and this was the result. So instead of showcasing the entire hypothesis matrix, you can actually showcase some charts that kind of talk the story for your hypothesis, whether they were true or false, and then kind of assimilate the results and you form one simple key action item. So if you just try to weave this into a simple picture, it's like it would look like a story by saying there was a decline in profits around 20% for a specific bank. The problem can be understood as the key factors that caused this decline were unknown, and the team looked into several factors ranging from macroeconomic factors to microeconomic factors and then figured out these key items and the impact of these key factors can be quantified with a couple of charts and then see that together we can say that To actually come out of this crisis, we need to take these action items which will tie back to these problems in this way. So that's a high level way of approaching storyboarding for the larger problem. And when you talk about the specific machine learning algorithm, the storyboarding exercise will actually include the importance of various features, showcasing the relationship, showcasing results from the ADS section. So the ADS section will actually be a long iterative exercises, and you'll have probably build hundreds of different plots. Picking up the key interest in plots, weaving them into a story, saying that this is the data set which we used. We found these patterns in the data set, and we built these features based on understanding. So let's say the person who is validating the scenario, looking at the feature engineering and exploratory data analysis, gets an understanding of what is the data talking in general. Then you talk about your machine learning use case, where you've developed the machine learning model. You kind of prepare the slide that you say, okay, then this is the use case which we had, and this was the technique which we used. So let's say for understanding the propensity of a customer to subscribe to a term deposit, we used a random forest model. We used a k-fold cross validation with k as 10 and show the different use cases, different outcomes and different cross validations. Showcase the evaluation metrics. So you'll have a bunch of different metrics and showcase a couple of iterations that in different situations, this was the kind of outcome you received. So that's the last part where you'll actually, and in fact, a very important part of the machine learning journey. It's important to showcase what kind of metrics you have used to evaluate a machine learning model. And it's also important to talk about a story that how did you approach this machine learning use case in a simplified way. You technically connect the dots, and if required, you'll connect the dot back to the main problem. That is the original problem which we discussed for the banking use case. So that's about it. The only thing which we have not touched base till now is productionizing the machine learning solution. So these days, Python is specifically used for productionizing the solution. Once you have a machine learning algorithm, you kind of put it into production where you take care of automatically making the data available for the machine learning model to run a prediction on. Once you make a prediction, you'll actually take into account where to store the recorded results, and you'll make a plan to actually evaluate the performance of this machine learning model over a period of time. Let's say you want to see whether the performance is changing every 1 week or every 1 month. And based on the kind of metrics you'll have, you'll make provisions to retrain the model. So you'll tune the parameters, you'll build additional trees, or with respect to your model, you'll take into account some actions to keep the model performing very well throughout the course for its use. And productionizing, we have a variety of tool sets available under cloud providers like Azure, AWS. So Azure and AWS, both of these leading providers have ready-made solutions where you can productionize machine learning models. So just a bit about it. I'm not getting the depth of it. That's beyond the scope for this project and for this course. So that's about it. We have started a wonderful journey to learn machine learning. We have started from basics of understanding the Python, from understanding the data science background, basics of like we started by understanding what are the different terms that we hear in this field. We have a lot of ambiguous terms and how do they differentiate from each other? How is each of them defined? We learned the data science toolbox, and then we picked up one specific language, Python, which is immensely popular these days as a data scientist language, preferred language. We explored basics of Python. We looked into basics of data visualization, data engineering, and data manipulation. In module 3, we understood the machine learning stack and explored EDA process and feature engineering process. We looked into the process of how we can leverage data visualization and data engineering to understand the data, study the data, and we learned basics of statistics. In module 4, which was a very long module, we understood machine learning techniques. We studied extensively different supervised machine learning techniques, unsupervised machine learning techniques. We understood about overfitting, underfitting, hyperparameter tuning. We understood how we can evaluate models in different scenarios, when it's a regression model, when it's a classification model. We also talked about what can be done in case of a clustering model. And then we looked into a Capstone project. I believe you would have got great results in this project. And by the end of this project, you would have actually gained expertise with the Python ecosystem, machine learning ecosystem, and the overall data science community. In module 5, I took special interest in showcasing the overall view of the project rather than just focusing on one specific machine learning use case. My approach was to actually showcase to you how does the problem evolve right from the business stakeholder view, then how does it boil down to the end. And of course, we did look at it from 100 feet. It was not a very granular level exploration. But in Module 5, I did expect that you would take up some time and explore a couple of activities on your own. We discussed the kind of roadblocks we would face, and we also discussed about approaches that we should take, alternatives that we should implement to circumvent these hurdles. So that's about it. We've had a great time together. It's been a long journey across 5 modules. I apologize for the long module, the fourth module being so long. I've had a great time and love to see you again in another course. Thank you so much and wishing you an amazing machine learning journey looking forward.